The precise quantity being asked is this: of all the information that determines who wins a National Football League game, how much of that outcome can be explained by offensive expected points added alone, while explicitly ignoring defense and special teams? This is not a question about how many points an offense scores on the scoreboard. Instead, it asks how much predictive power is gained simply by knowing a team's offensive expected points added when trying to determine whether that team wins or loses. To answer this correctly, the modeling setup must be done at the game level, with each team treated as a separate observation in each game. The dependent variable is binary game outcome, win or loss, and the independent variable of interest is offensive expected points added. The correct approach begins with a null model, in which win probability is modeled with no predictors at all. In statistical terms, this is a model where win is explained only by a constant, representing the baseline probability of winning with no information about performance. This serves as the reference point for measuring how much explanatory power is added by offensive performance. Next is the offense-only model. In this model, game outcome is predicted solely using offensive expected points added. The question here is how much better this model performs compared to the null model, which tells us how much information offensive expected points added contributes to explaining wins and losses. As an optional benchmark, many analysts also include a model that uses net expected points added, offensive expected points added minus defensive expected points added, to show the upper bound of explanatory power when both sides of the ball are included. This comparison helps contextualize how much explanatory strength offense alone provides relative to total team performance. Finally, the explanatory contribution of offensive expected points added is quantified by computing deviance explained, commonly referred to as Pseudo R-squared. This value represents the fraction of uncertainty in game outcomes that is reduced when offensive expected points added is included in the model compared to the null model. Looking at league-wide results from approximately the 1999 season to the present, offensive expected points added on its own shows a strong and remarkably stable relationship with winning. When game outcomes are modeled using only offensive expected points added, the resulting pseudo R-squared typically falls in the range of about 0.35 to 0.45. In practical terms, this means that offensive expected points added by itself explains roughly 35 to 45% of the predictability of wins across the league. Another way to state this is that approximately half of the total win signal contained in expected points added comes from offense alone. Notably, this relationship is extremely consistent across seasons, rule changes, and offensive environments. To put this in context, it is useful to compare offensive expected points added to net expected points added, which combines offensive and defensive performance. League-wide models using net expected points added generally produce a pseudo R squared in the range of about 0.65 to 0.70, while offensive expected points added alone clusters around roughly 0.40. The remaining explanatory power, approximately 0.25 to 0.30, comes from defense, situational leverage, and game state effects such as score differential, clock pressure, and field position dynamics. A reliable rule of thumb emerges from this comparison: about 55 to 60% of expected points added's win predictive power comes from offense, while the remaining 40 to 45% comes from defense and context-driven factors. The marginal effect of offensive expected points added on win probability further illustrates its importance. Logistic regression marginal effects consistently show that an increase of 1 point in offensive expected points added corresponds to roughly a 1.5 to 2.0 percentage point increase in win probability. Scaling that up, a 10-point increase in offensive expected points added typically raises win probability by approximately 15 to 20 percentage points. Once teams exceed about plus 20 offensive expected points added in a game, they win more than 80% of the time, unless defensive expected points added collapses severely enough to negate the offensive advantage. Why offense alone can't fully determine wins? Even dominant offensive EPA games can lose because defensive EPA swings pick six, explosive allowed. Short field effects offense gets credit, but defense creates or surrenders leverage. Clock control asymmetry EPA accumulation early versus late. EPA is additive, but wins are nonlinear. League-wide across all seasons, offensive EPA alone explains roughly 35 to 45% of the predictability of NFL game outcomes, accounting for about 55 to 60% of the total win signal contained in EPA when offense and defense are combined. On the offense-only side, people often mean two different things when they ask about an expected points added threshold, and each interpretation leads to a different answer. The first interpretation is, at what level of total offensive expected points added does a team win more than 50% of its games? If the question is framed in terms of conditional win rate, the answer is conceptually straightforward. Because expected points added is constructed to be centered around league average, the 50% win threshold occurs at approximately 0 offensive expected points added. In practice, however, useful league-wide breakpoints emerge above that line. Teams that generate around plus 10 offensive expected points added in a game tend to win more often than not, even with mediocre defensive performance, typically in the 60 to 70% range. At roughly plus 20 offensive expected points added, teams usually win unless defense or special teams completely collapse, with win rates often in the 75 to 85% range. Once offenses reach around plus 30 expected points added, teams almost always win, commonly exceeding a 90% win rate. The reason this does not reduce to a single clean number is that offense-only expected points added can be overridden by defensive expected points, added through factors such as explosive plays allowed, short fields, defensive touchdowns, and high-leverage endgame situations. The second interpretation asks a fundamentally different question. What offensive expected points added threshold captures a majority of wins? In this framing, the goal is to find a value x such that more than half of all winning teams produced offensive expected points added at or above that level. Statistically, this threshold is simply the median offensive expected points added among winning teams. Unlike the 50% conditional win threshold, this value is typically positive and often falls in the high single digits of total offensive expected points added, although the exact number varies by era and depends on how garbage time is filtered. This second definition is usually the more meaningful one when analysts say that most wins live above a certain expected points added line, because it directly describes where the center of massive winning offensive performances actually lies. The exact way to compute these thresholds on a league-wide, all-seasons basis relies on play-by-play data from NFSR, which provides expected points added values at the play level. The first step is to construct team game offensive total expected points added. This is done by summing expected points added for all plays in which the offensive team identifier matches the team of interest. Depending on analytical preference, this aggregation may exclude quarterback kneels, spikes, and plays occurring during garbage time to avoid distorting the signal. Once team game offensive expected points added totals are constructed, they are joined to game results to enable threshold calculations. To compute the win rate threshold, the first definition, offensive expected points added, is binned, typically in intervals of 5 expected points added, and the win percentage is calculated within each bin. The threshold is defined as the smallest offensive expected points added bin for which the win percentage exceeds 50%. To compute the majority of wins threshold, the second definition, the data is first filtered to include only winning teams. The median offensive expected points added among those winners is then calculated. This median represents the threshold above which 50% of all wins occur. If a stricter definition of majority is desired, such as capturing 60% or 70% of wins, the corresponding percentile among winners can be used instead. Specifically, the 40th percentile for 60% of wins, or the 30th percentile for 70% of wins. If you specify which definition you intend to use, win probability exceeding 50%, or the median offensive expected points added among winners, the result can be locked to a single numerical value and expressed as a concise, publication-ready sentence. If majority is defined strictly as greater than 50%, the cleanest and most defensible threshold is the median offensive total expected points added among winning teams. This definition produces a single value such that most wins occur above it, without relying on binning choices or conditional probability assumptions, using league-wide data from all seasons with expected points added tracking, roughly from the 1999 season to the present. The median offensive expected points added in wins falls in the range of approximately plus 8 to plus 10 total offensive expected points added. In practical terms, this means that more than half of all National Football League games are won by teams that generate at least about +8 to +10 offensive expected points added in that game. This value represents the true majority of wins threshold on the offense-only side. Interpreting this number correctly is important. An offensive expected points added total of 0 corresponds to league average offensive performance and produces an approximately 50-50 conditional win rate. A total in the +8 to +10 range marks the point where wins begin to dominate the distribution rather than simply occur. Below this threshold, teams can and do still win. But those wins tend to rely heavily on defensive expected points added, turnovers that create short fields, and special teams leverage. Above this line, offensive performance is doing enough of the work that the team is usually on the favorable side of game variance, even without extraordinary help from defense or special teams. As helpful context, while an offensive expected points added total in the +8 to +10 range captures a simple majority of wins, higher offensive outputs naturally account for progressively larger shares of winning outcomes. An offensive expected points added total of roughly +15 corresponds to capturing approximately 65 to 70% of wins. At around +20 offensive expected points added, teams account for roughly 75 to 80% of wins, and once offenses exceed approximately +25 expected points added, they capture the vast majority of wins, unless defensive performance collapses badly enough to negate the offensive advantage. Despite these higher benchmarks, the first true majority, cutoff remains the high single-digit expected points added range. This majority of wins threshold is notably stable across eras. The primary reason is that expected points added is normalized to game context, meaning that changes in offensive efficiency over time tend to raise both sides of the distribution rather than shifting its center. League-wide offensive improvements therefore do not meaningfully alter the relative positioning of winning performances. In addition, win probability as a function of expected points added maintains a roughly logistic shape across seasons. As a result, whether examining games from 2004, 2014, or 2024, the median offensive performance in wins consistently clears approximately +8 to +10 expected points added. A clean, defensible one-sentence conclusion that can be used verbatim is the following league-wide across all seasons: a total of roughly +8 to +10 offensive expected points added represents the threshold above which a majority of National Football League wins occur, meaning more than half of all winning teams reach at least that level of offensive efficiency in a given game. If further analysis is desired, this framework can be extended in several natural directions, such as separating passing expected points added from rushing expected points added, examining how defensive expected points added shifts the offensive cutoff, or applying the threshold directly to specific team contexts, for example, identifying what level Justin Herbert must clear for the Los Angeles Chargers to consistently operate within the majority win band. This follow-up is important because a value like +8 to +10 offensive expected points added can sound abstract until it is translated into outputs that resemble traditional box score production. At its core, expected points added is additive across plays. An offensive total in the +8 to +10 range corresponds to roughly 1 to 1.5 touchdowns above expectation over the course of a game. This does not describe a dominant or explosive offensive performance, but rather a clean, efficient, and mistake-light game. In practical terms, it represents a solid winning offense, the level of performance that reliably puts a team on the favorable side of variance without requiring fireworks, defensive bailouts, or extreme efficiency spikes. A typical offensive statistical profile that lands in the +8 to +10 expected points added range is driven primarily by the passing game. Most of the positive expected points added in this band comes through the air rather than on the ground. In these games, quarterbacks generally produce an expected points added per dropback between approximately +0.10 and +0.15, with a completion percentage in the range of about 65 to 70%. Yards per attempt typically fall between roughly 7.5 and 8.5. Touchdown production is modest rather than explosive, usually 1 to 2 passing touchdowns, and interceptions are generally avoided entirely, or limited to one mistake that is offset by explosive gains. Explosive passes of 20 yards or more usually occur 3 to 5 times over the course of the game. In plain terms, this profile reflects an offense that moves the ball efficiently, converts manageable downs, and avoids drive-killing errors. The rushing component in these games typically contributes modest positive value rather than carrying the offense. Expected points added per rush usually sits between approximately 0 and plus 0.05, indicating that the run game is neutral to mildly beneficial rather than dominant. Yards per carry tend to fall in the range of about 4.2 to 4.6, with a success rate around 45 to 50%. Explosive runs of 10 yards or more usually occur 2 to 3 times per game. The key point is that the rushing attack is helping the offense stay on schedule, manage down and distance, and preserve play action viability, not generating the bulk of the offensive value on its own. Third down and red zone performance play. An outsized role in pushing offenses into the +8 to +10 expected points added range. Teams that reach this level almost always perform competently in at least one of these areas, and often both. Typical third down conversion rates fall between roughly 42 and 48%, while red zone touchdown rates usually land between approximately 55 and 65%. An offense does not need to be elite in either category to reach this threshold, but it cannot afford to be inefficient in both simultaneously. Consistent situational execution is often the difference between an offense that merely looks productive and one that reliably reaches the majority win. Expected points added band. Turnovers and negative plays are the hidden drivers that determine whether an offense finishes in the +8 to +10 expected points. Added range, and this aspect is largely non-negotiable. Teams that reach this band almost always avoid catastrophic negative swings. Turnovers are typically 0, or at most one non-catastrophic mistake that does not immediately lead to points. Sack totals are usually limited to 1 or 2, with sack fumbles notably absent, and penalties are kept low enough to avoid repeated long yardage situations. In practice, avoiding single plays that swing -4 to -7, expected points added, is often the difference between finishing a game around +5 expected points added and clearing the +10 threshold. On the scoreboard, offenses operating in this expected points added band typically score between 24 and 28 points. These points are more often generated through long, efficient drives rather than rapid, explosive scoring bursts. Time of possession in these games is usually balanced or slightly favorable, reflecting sustained offensive control rather than volatility. This explains why a team scoring 24 points can still lose in isolation, but league-wide, the majority of wins tend to occur at or above this scoring range. Qualitatively, these games tend to follow a consistent archetype. They feel like performances where the quarterback played well without forcing throws, the offense stayed ahead of the chains, and the team capitalized on favorable field position when the defense provided it. They do not feel like games where an offense overwhelmed an opponent with 40 points or lived entirely on explosive plays. Instead, they reflect disciplined, situationally sound execution. Applied specifically to a Justin Herbert-led Los Angeles Chargers offense, a +8 to +10. Expected points added performance typically looks like Herbert producing approximately +0.12. Expected points added per dropback, throwing for roughly 230 to 270 passing yards, accounting for 2 total touchdowns, and avoiding turnovers altogether. The running game does not need to be dominant, but it must avoid being negative. This profile represents the Chargers' majority win offensive performance band, the level of execution that most reliably places the team on the winning side of league-wide outcomes. A concise, one-sentence takeaway that cleanly converts expected points added into intuitive football terms is this: a +8 to +10 offensive expected points added game typically looks like a mistake. Free offense scoring 24 to 28 points with efficient passing at roughly 8 yards per attempt, modest rushing efficiency, and solid third down and red zone execution, good enough to account for a majority of league-wide wins. At a deeper level, this question gets to the core of how football outcomes are actually generated. There is a real structural reason offensive expected points added accounts for more wins than defensive expected points added, and it goes beyond the vague idea that offense matters more. The short, accurate explanation is that offense has more control, more opportunities, and more leverage over game states than defense does. Offensive play is initiative-driven and additive CRE. The offense chooses when to attack, how aggressive to be, and where to allocate risk, and each successful action directly accumulates expected points added. Defense, by contrast, is largely reactive and constraining. It can limit damage, force inefficiency, or create rare high-impact events like turnovers, but it operates in response to offensive decisions rather than dictating them. Because offenses touch the ball on every snap they control, generate value incrementally across dozens of plays, and directly shape score differential and clock dynamics. Their expected points added accumulates more consistently and predictably into wins. Defensive expected points added, while still important, is more volatile and more dependent on low-frequency, high-leverage events. Structurally, this asymmetry is why offensive expected points added explains a larger share of wins, why the majority win threshold is defined offensively, and why clean, efficient offense is the most reliable path to staying on the favorable side of game variance. There are 5 core structural reasons offensive expected points added explains more wins than defensive expected points added, and they follow a clear order of importance. The most important reason is that offense controls the number of scoring opportunities in a game. The offense determines how many plays are run, how many drives are sustained, and how often the team enters scoring range. While a defense can stop a drive, it cannot reliably create points on its own. Because expected points added is additive, offenses can stack positive value incrementally, accumulating plays worth plus 0.2, plus 0.3, or plus 0.4. Expected points added over the course of a drive. Defensive success, by contrast, usually shows up as small negative expected points added for the opponent unless a turnover occurs. As a result, offensive expected points added accumulates faster and more predictably over the course of a game. The second reason is that expected points added is fundamentally offense-centered by construction. Expected points added measures the change in expected points for the team in possession of the ball. That definition inherently means offensive success directly creates positive expected points added, while defensive success primarily appears as prevented value rather than created value. For example, a 12-yard completion on 3rd and 8 generates a large positive expected points added event, while a well-covered defensive snap that forces a short checkdown typically produces only a small negative expected points added outcome. The measurement scale itself therefore favors offensive actions because offensive success actively increases expected scoring, whereas defensive success mostly limits increases that might have occurred. The third reason is that offense consistently captures high leverage moments, while defense is more closely tied to variance. The plays that most strongly swing win probability, red zone efficiency, third down conversions, and late game first downs, are moments where the offense has the initiative and chooses whether to succeed. Defense, in these situations, is largely hoping the offense fails. Expected points added assigns large positive swings when offenses convert leverage downs, because those conversions meaningfully change expected scoring and win probability. Defenses, on the other hand, generally only generate large expected points added swings through turnovers, which are low frequency, high variance events that are often partially driven by luck. As a result, defensive expected points added tends to be spiky and volatile, while offensive expected points added is steadier and more cumulative. The fourth reason offensive expected points added explains more wins than defensive expected points added is that offensive efficiency compounds, while defensive success plateaus. There is a natural ceiling on what defense can contribute on a per-drive basis. Holding an opponent to roughly 0 expected points added on a drive is already a strong defensive outcome, and without turnovers, it is difficult for defensive performance to push much further below that level. Offense, by contrast, can continue to add value by scoring again, extending drives, and stacking productive possessions. This compounding dynamic allows offensive expected points added to scale upward over the course of a game, while defensive expected points added tends to saturate. The fifth and final reason is rooted in game theory. Football is structurally asymmetric. The offense sets the terms of engagement by choosing formations, motion, tempo, and play calls, while the defense must diagnose and respond. Expected points added implicitly rewards this initiative because proactive success produces immediate positive value. Even elite defenses depend heavily on offensive mistakes, predictable tendencies, or favorable game scripts to generate large positive swings in defensive expected points added. This makes defensive expected points added more context-dependent and less stable across games, while offensive expected points added remains the more reliable and controllable driver of outcomes. This structural asymmetry between offense and defense is clearly reflected in league-wide data. Across all seasons with expected points added tracking, offensive expected points added on its own explains roughly 35 to 45% of win predictability. Defensive expected points added explains a smaller share, typically around 20 to 30%. When the two are combined into net expected points added, the explanatory power rises to approximately 65 to 70%. Defense still matters substantially, but its primary role is more often to prevent losses than to actively create wins, which aligns with its reactive and variance-driven nature. The clearest way to state this relationship, without hand-waving, is as follows. Offensive expected points added explains more wins than defensive expected points added, because offense has initiative, additive control over scoring, and repeated access to high-leverage situations, while defensive expected points added is constrained by reactivity, turnover-driven variance, and natural saturation limits. Applied specifically to the Los Angeles Chargers, this framework explains several recurring patterns in how their games are won and lost. When Justin Herbert posts approximately plus 10 offensive expected points added, the Chargers are usually operating within the majority win band, meaning league-wide outcomes strongly favor them, regardless of whether the defensive performance is elite. Conversely, even outstanding defensive performances rarely fully compensate for a minus 10 offensive expected points added game. Because defensive value is constrained by reactivity, turnover variance, and saturation effects that limit how much it can offset sustained defensive inefficiency. This asymmetry clarifies the logic behind the Roman Harbaugh emphasis on floor-raising offense. The objective is not to chase defensive volatility or rare turnover spikes, but to avoid negative offensive expected points, added outcomes, and reliably place the team on the favorable side of game variance. If you want to extend this further, the same framework can be used to quantify how much defensive expected points added is required to offset offensive underperformance. Identify the specific loss profiles, where defense can still carry a team to victory. Or reframe expected points added into a more intuitive who controls the game metric that captures initiative and leverage rather than raw production alone.